morning, all of you. My name is Arvind Gautam, and I am working as a assistant professor in AKGEC Girl Engineering College. Okay. Our today topic is serializability. In previous video, I have discussed with you the transaction processing concept. So in transaction processing concept, I have discussed the acid properties. So in acid property, we have discussed what is atomicity, what is consistency, isolation, and what is durability. So atomicity is the entire transaction take place at once or doesn't happen at all. And consistency, that the database must be consistent before and after the transaction. And third is isolation. Multiple transactions occur independently without interference. And fourth one is durability. The changes of a successful transaction occurs even if the system failure occurs. So these are the four acid property of transaction processing concept that we have discussed in the previous video lecture. So today topic is serializability. This is another main concept of transaction processing concept, that is serializability. So today we will discuss what is serializability. So what is serializability? A schedule is serialized if it is equivalent to a serial schedule. A concurrent schedule must ensure it is the same as if executed serially, means one after another. It refers to the sequence of actions such as read, write, abort, commit are performed in a serial manner. That means we can say that a serializable, that means what a schedule has the ability to become a serializable. Okay. So what is the schedule? A schedule is a collection of transaction, and transaction we have discussed in the previous video lecture. What is the transaction? Okay. So through serializability, say that can I make serializable to that schedule? Okay, let's see the example. What is serializability? Okay, there is a one schedule. I have told you that schedule is a collection of transactions. So there is a schedule 1. There are two transactions, that is T1 and T2, and their operations are: T1 first do the operation, a write operation on the dataset A, and after that read, and then after that write operation. After that, transaction T2 come in the schedule and do the operation, that is read and write operation after the transaction T1 on the same data set A. So it is clearly, you can see here, it is clearly show that this schedule, in this schedule there are two transactions T1 and T2, both are serial. It is clearly seen here. You can see that both transactions are serial. Okay, you can check. In this schedule, here you can say that transaction T1 first come in the schedule and did a read and write operation on the dataset A. After finish, when it finished his work, after the transaction T2 take place, after finish, then of transaction T2 come in the schedule and do the read and write operation on the same data set. Okay. So from the precedence graph, you can say that transaction T1 come first, and then it complete all the operations. After that, transaction T2 come in the schedule for doing their operations. Okay, so you can see here there is no conflict. So this is a serial schedule. Okay, another example, I am taking in another example. There is a schedule and there are two transactions, that is T1 and T2, and their operations are read it, write it. In this schedule, the transaction T2 come first, and the transaction T2 is doing the read and write operations. After that, T1 comes in schedule and doing operations, read and write operation on the same data set. Okay. So here you can say that the transaction T2, when complete its transaction after the transaction T1 take place. Okay. Or you can say that is doing their operations on the same data set when T2 when finishes all the operations on the data set A. So it is a serial transaction. It is a serial. You can say that here is no conflict. So you can say that this is a serial. Okay. From precedence graph, you can say that transaction T2 come first, or you can transaction T2 come first after the transaction T1 take place. After finishing the T2, then T1 take place. So this is a serial schedule. You can say that there is no conflict, then this is a serial schedule. So there are no conflict, there is no any problem when schedule is a serial schedule. Okay. So it is so there is no any chances, or you can say that it is already in a serial schedule, so there is no need to convert, or you can say that no need to change in the serial, because it is also it is already in a serial schedule. So there is no need to change in serializability. You can't change, you can't check it is serializable or not, because it is also in a serial schedule. Okay, so let's take another example. Let's take another example, parallel schedule. Let's take an example of parallel schedule. Okay, parallel schedule. Okay, there is a two transaction T1 and T2. Transaction T1 and T2, and their operations are: first, transaction T1 take place and doing their operations, that is read operation on data item A, and after that T2 comes in the schedule and doing transaction on the same data set and doing read and write operation on the same data set. Okay, transaction T1 was not completed. Okay, on that point of time, transaction T2 comes in the schedule and doing their transaction. Okay, after that T1 will finish his operation, so after that T2, after T2, T1 will occur again. Okay, and will do their transaction again, write operation. Okay, so this is a parallel schedule, you can say that. So here we can you say that it is a serial or not? No, you can't say that it is a serial. Okay, so here we can check from the precedence graph that it is serial or not. So in precedence graph, here you can make do transaction T1 and T2. Okay, first transaction come place in the schedule, that is T1, and did a write operation, and after that T2 will occur and doing their transaction read and write operation. Then T1 goes to T2. Okay, after that T2, after T2 again T1 comes and doing their transaction on the right, on the same data item, and doing write operation. T1 to 2, and then T2, after that T1 take place. So you can say that there is a loop. So there is a loop. Here you can clearly see that there is a loop. So this is a parallel schedule. Okay, so this parallel schedule we have find a, so there is a loop. So you must change this parallel schedule in a serial schedule. Okay, so the parallel schedule we have to find a clone, that schedule that should be serializable. Okay, the parallel schedule we have to find a clone that should be serializable. Okay, so for converting this schedule in the serializable schedule or serial schedule, so we can do first you can do that we can change the position of write operation of transaction T1. Here you can write. Okay, then clearly you can say that there is a no conflict between T1 and T2. T1 when finish its all operation, after that T2 comes in the schedule and doing their operations. Okay, and vice versa you can. So the precedence graph according to this operations, you can say that T1 occur first, after that T2 comes in the schedule. Okay, through this you can change in the serializable, you can change in serial, and there is another way you can change this. Just suppose T2 will occur first and doing their operation read and write operation at same data item. After that T1 occur in the transaction and doing their transaction, doing their operations on the same data item. So the precedence graph is T2 goes to T1. Okay, or you can say that. Okay, from this operation you can from these two operation we can change this parallel schedule in the serial schedule. Okay, okay, to check parallel schedule as serializable, what you have to check that what equivalent to this, does any serial schedule exist or not. Okay, so that concept we say serializability. Okay, means to check parallel schedule as serializable. Okay, what you have to check that what equivalent to this, does any serializable schedule exist or not? So that concept we say serializability. Okay, so there are two methods take place in this serializability. One is conflict serializability, and second is view serializability. Okay, so we will discuss one by one. First, we will see what is conflict serializability, and after that we will see what is view serializability. Okay, first is conflict serializability. Here we will see first what is conflict serializability. Okay, so first we will take example for conflict serializability. Okay, so we will see the conflict serializability with an example. There are three transactions T1, T2 and T3. Okay, and their operations are first transaction T1 comes in the schedule and doing their read operation on the data item X. Okay, after that transaction T3 comes in the schedule and doing read operation on the data item Y. And after that, it's an example I am taking so that we can solve the conflict serializability. Okay, after that T2 and data item is RY and RZ. We have to clear that conflict pairs if the transactions operation working on the same data item, then there is a conflict. If the transaction T1 is working on the X data item and transaction T2 on T3 is working on the another data item, then there will be no any conflict between the transactions. Okay, it will be clear. Okay, after that transaction T3 again comes in the schedule and doing a write operation on Y data item. After that transaction T2 again come and write the data item Z. Okay, after that transaction T1 read on data item Z and write operation on Z, and after that write operation on X. Okay, X data item. Okay, so this is the transaction of conflict serializability. This is an example, just okay. So first we have to draw the precedence graph. Okay, precedence graph. What is precedence graph? We have to know what is vertex and edges. So vertex is a number of transactions. Though there are three number of transactions, so there will be three transactions will take place. And second one is edges. Edges check conflict pair in other transactions and draw edges. Okay, so we will draw the edges on the we will check the conflict pairs. And what is the conflict pairs? Conflict pairs is between read and write operation, write and read operation, and write and write operation. This is the conflict pair. And another thing is we will see that if read and write are conflict, then on date same data item, on date same, not another data item. If a read operation on A operation take place in doing on the data item A, and write operation, another transaction that is doing write operation on another B data item, then there will be no conflict. Conflict is take place it will take place only on the one condition, when both read and write, or write or read, or write operation is doing or working or doing operation on the same data item. Okay, then there will be a conflict. Okay, we will see. Okay, precedence graph. First we will see the precedence graph. Okay, so here we can say that in transaction T1 will occur first, though, and vertex number of transaction 3. So we will draw the 3 vertexes, vertex T1, T2 and T3. Okay, after that transaction T1 come place, we will check one by one. Okay, if there is any conflict or not, and conflict pairs are read write, write write, or read write. This is a conflict pair. So first, read a data item on X. So there will be any conflict pairs, we will compare to the other transaction. Read, after that T3 take place, read, no conflict, read. Then after that T2 take place, read, no conflict. After that write operation take place, but it is working on the another data item, so there will be no any conflict. After that write operation on working on another data item, though there will be no any conflict pair. So I have checked the transaction T1, so there is a no conflict. So transaction T1, okay, so it is checked, there is a no conflict. Okay, so after that transaction T3 will occur in the schedule, and we will check the conflict pair, read operation and working on the Y data item. So there we will compare with another transaction that there is any conflict or not. So read ka write, read write, there is any conflict pair. First we have to check with T2 transaction, read no, read Z. After that WZ, read another data item, there is no conflict. Read Y, read Z, there is no conflict. Okay, I have checked, there are no any conflict pair. Okay, after that we will check RX, read operation on X data item. Okay, RX, there is any conflict, we will compare with the another transaction, no conflict pairs. After that no conflict pairs, RX and WX. Yes, read will making conflict pair with the write operation. So there is a read operation is conflict with the write operation on the same data item. So there is a conflict pair from T3 to T1. So we will make a edges. What saying that check conflict pair in other transaction and draw the edges on the behalf of this conflict pairs. So T3 goes to T1. Okay, after that After that, we will check the then read operation will come in the schedule. So we will check the conflict pair read, write, read and write. There is a conflict pair between the read and write operation. Read, write operation on the same data item. Okay. On the same data item. Okay, we will check. So transaction will go to T2 to T3. T2 to T3. Okay, I have checked this. After that, RZ comes in the transaction schedule. RZ. So there is any conflict pair read, write. But there is it is working on a different data item. RZ, same data item. WZ. Okay. There is a pairs read and write. RZ or WZ. Okay. T2 is conflict pair is making conflict pair with T1 WZ. So we will make the edges T2 goes to T1. T2 goes to T1. Okay, it is checked. After that, T3 comes in the schedule and working on the data item Y write operation. So there is any conflict pair, write conflict pairs with the write operation and read operation. So there is any conflict pair, write different data item, write, read different data item, write or write, but there is a different data item. Okay. WX. Okay, so I have checked there is no any conflict pairs. After that, WZ write operation. Yes, there is a conflict. T2 goes to T1. So we have already make the edges between the T2 to T1. Though no need to create another edges. Okay. WZ I have checked. W and W conflict. There are another conflict pair between write and read operation on same data item. Okay, T2 goes to T1. Okay, there is no need to create another data set, the edges. Okay, so we have checked all the transactions and we have made a precedence graph. Okay, there is no comparison in another transaction. We are saying we can say that there is no any operation, so we can't compare this transaction with another operation. So we can say that we have checked all the operations of T1 also. So this is our precedence graph according to the conflict pair of these examples. We have made a precedence graph. So in precedence graph, we you can say that from the precedence graph there is any loop between the vertex. Okay, first we will see that transaction T1. There is a no loop. Transaction T1, T2 and T3. So there is a no loop. So there is a no loop and you can say that there is a no any cycle exist. Okay. So there is a no loop. So this is a conflict serializable. You can say that this is a conflict serializable. Okay. If there is any loop exists, so that will not conflict serializable. So later on we will see on another video lectures, and from this conflict serializability, if any loop exists, then we will check that schedule is serial or not. Okay, if any loop exists, if loop exists, then we will check through the view serializability, that is serial or not. And if it is there is no loop, so we can say that this schedule or this transaction is a conflict serializable. Okay, if it is a conflict serializable, then you can say that it is a serial schedule. If it is serial schedule, then you can say that it is a consistent schedule. Okay, and another term is what is the sequence of this transaction? What is the sequence? What is the sequence? Sometimes in exams ask you that what is the sequence of this transaction, this conflict serializabilities. Okay, so through this precedence graph you can make the sequence, possible sequence you can make. Okay, so the sequence, this is the possible sequence of this precedence graph. So we will check what is the possible, in which one is the possible sequence of this precedence graph. We will check. So how we will check? First we will see the incoming edges. In degree will be 0. In degree, first is in degree will be 0. In degree will be 0. In degree means incoming edges. In vertex there is no incoming edges. In T2 we will see that there is no any incoming edges. So first sequence comes in our mind, or you can say that T2 is your first transaction that will comes in your sequence. Okay, after that you can remove this T2 and you can clearly see that after that we will check incoming edges. Any incoming edges is there? In T3 there is no any incoming edges. So our next sequence is T3. Okay, T3. After that we will see, we can erase this, and last but not the least, we can make, and last it is last T2, T3, T1 is the only transaction of this schedule. Okay, it exists. So our next sequence will be T1. So the whole sequence, you can say that T2 goes to T3, T3 goes to T1, T2 goes to T3, and T3 goes to T1 will be your sequence. Okay, according to this precedence graph that we have made. Okay, so that's all for the today class. Thank you so much.